All right, welcome to screencast number 1 for Unit 3, Lesson 3. This is about electrons and chemical bonding. Our essential question is, how do atoms interact with each other? And by the end of this lesson, you should be able to use atomic models to predict whether atoms can form bonds. And just a note, make sure that you go back and answer all of the active reading questions, starting with number 1 on page 137. All right, I'm now on page 138. How do atoms join together? There are only 26 letters in the English alphabet, yet you can combine those letters in different ways to form nearly 1,000,000 words. Similarly, there are a limited number of elements, but their atoms join together in different ways to form the many, many substances around you. Some substances, such as water, are made up of only a few atoms. Other substances, such as DNA, contain billions of atoms. A huge variety of substances are possible because atoms join together by forming chemical bonds. A chemical bond is an interaction that holds atoms or ions together. A group of atoms that are held together by chemical bonds is known as a molecule. Okay, look at the model of a water molecule below. Every water molecule is made of one oxygen atom bonded to two hydrogen atoms. The chemical bonds hold the atoms together. Okay, I'm not going to answer number 5 for you because the definition for chemical bond is in the paragraph above. Okay. Draw arrows that point to the location of chemical bonds in the water molecule. Okay, the oxygen atom is red and the hydrogen atoms are blue. Remember that your chemical bonds are going to be between electrons, either electrons that are being gained, lost, or shared. So your chemical bonds are probably going to be illustrated sort of at the boundary line between the hydrogen and the oxygen molecules. Okay. Page 139. What happens to atoms during chemical changes? Chemical changes change the identity of substances. However, a chemical change does not create or destroy atoms. Instead, the atoms are rearranged to make new substances with different properties. Okay. Down at the bottom, atoms are rearranged. In order for atoms to be rearranged, chemical bonds have to be formed or broken. The model below shows how hydrogen gas and chlorine gas undergo a chemical change to make hydrogen chloride. Initially, there are bonds between the hydrogen atoms and bonds between the chlorine atoms. In the chemical reaction between hydrogen and chlorine, these bonds break. A new bond forms between each chlorine atom and hydrogen atom. The atoms that make up hydrogen gas and chlorine gas still have the same number of protons, so they don't change their identities. Instead, the atoms are simply rearranged to form hydrogen chloride. Now, I do need to say something that's very important for you to understand, and that is, for instance, if you look down at the bottom where it is illustrating the reaction of hydrogen gas plus chlorine gas, I need you to understand that the properties of hydrogen gas and the properties of chlorine gas are completely different than the properties of hydrogen chloride, which is the compound that they make. Okay? Another great illustration for you to think about, table salt is sodium chloride. Okay? Sodium by itself, elemental sodium, is a corrosive, very reactive metal. It's one of the ones that we saw them toss into water on the periodic videos. So it's a very, very reactive metal. Chlorine by itself is a poisonous gas. But when chlorine and sodium chemically react to form sodium chloride is table salt, and we have table salt all the time. We have it on our food all the time. So my point in saying that is that the properties of the compound that's formed, those properties are completely different than the properties of the individual elements that combine to make that compound. Please, 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 please understand that. That is very, very important. Okay? All right, down at the bottom on number 7, the hydrogen molecules and the chlorine molecules, where it says the plus sign, those two things are entering into a chemical reaction with one another, so they're known as reactants. The compound that is produced, hydrogen chloride, the substances that you get as a result of the chemical reaction or at the end of the chemical reaction are known as products. Okay? All right, I'm now on page 140. What do different atom models show? Because atoms are too small to observe directly, scientists often use models of the atom to show how atoms behave. Remember, we use models to represent things that are either too big, too small, too far away, or too dangerous for us to observe directly. Okay? So atoms, we're going to make a model of atoms because they're too small for us to observe directly. They use different models depending on what they need to study. For example, the way a model shows electrons is important because electrons are involved in chemical bonding. 3 different models used to represent atoms are shown at the right. The electron cloud model is the top one. So the electron cloud model of a hydrogen atom is shown at the top. This model shows how electrons are found in a region around the nucleus. So the blue area is that electron cloud region. It helps show the general locations of the different parts of the atom, but it does not show the number of electrons. The second one, the Bohr model of a hydrogen atom, is shown in the middle. This model does show the number of electrons in an atom. The electrons are shown as dots placed in rings around the nucleus. Bohr models do not show the true arrangements of electrons in the atom. Each ring represents an energy level, not a physical location in the atom. However, showing the electrons and energy levels helps predict how and when atoms form chemical bonds. The third model we have is the space-filling model of a molecule, and it is shown at the bottom. In this type of model, atoms are represented as solid spheres. The spheres do not show the parts that make up the atoms, but this model clearly shows how the atoms are connected to one another. Okay. What I'm going to do at this point is I'm going to go back a couple of pages and I'm going to show you what you probably need to highlight and underline and make a note of. All right, here's what I have on page 138. I went back and highlighted the last 2 sentences of the first paragraph that says, a huge variety of substances are possible because atoms join together by forming chemical bonds. A chemical bond is an interaction that holds atoms or ions together. A group of atoms that are held together by chemical bonds is a molecule. On page 139, under what happens to atoms during chemical changes change the identity of substances. However, a chemical change does not create or destroy atoms. Instead, the atoms are rearranged to make new substances with different properties. Under the red heading where it says atoms are rearranged, I highlighted the first sentence. In order for atoms to be rearranged, chemical bonds have to be formed or broken. And down at the bottom, under number 7 where it says visualize it, I drew a bracket and labeled the reactants and made a note that there are a total of 2 atoms of hydrogen and made a note that there are a total of 2 atoms of chlorine on the reactant side. The arrow in this chemical equation means yields or produces. Okay, I drew a bracket around the products and labeled them. And notice on the product side, I still have a total of 2 hydrogen atoms and 2 chlorine atoms. Okay. And number 9, how can you tell that the atoms are not created or destroyed by the chemical change? Because there are the same number of atoms of each element on both sides of the reaction. Okay, and then if you notice, something else has popped up on page 139. I added a little bubble to remind you that it's only valence electrons that are involved in chemical bonding. Okay, not even all the electrons, just the valence electrons. Okay, and remember that in chemical bonding, in chemical reactions, nothing is happening to anything in the nucleus. It only involves electrons.